Hello, I'm Giovanni Paul, and I'm the Smart Mobility Chair at the University Pierre and Marie Curie in Paris, France. Today I will talk about connected cars. Cars are becoming very different from what they used to be. Specifically, they are now service providers, not only transportation providers. Connected cars in the future will provide services that enhance safety of driving, will provide services that will allow, for instance, to crowdsource parking using the camera that is mounted on the car. And with the autonomous driving, cars will also become large sensor platforms that are on our streets, and they will have a lot of data to be transferred to the cloud in order to improve the global driving experience that is needed to have a performant autonomous driving system. How we connect our cars? That is one problem. So there are a lot of technologies out there. The first one is named the SRC. The SRC was encouraged by the FCC in the United States as a technology to improve safety at the intersections. The idea is that cars will be equipped with the SRC radios and they will be able to send messages to other cars on the road in order to alert the driver that there is an hazard. However, the SRC basically at the moment has no infrastructure, so it's very hard to use it to connect the cars to the internet because that requires the installation of thousands, tens of thousands of access points globally. Furthermore, the SRC has been designed for safety. That means a very large number of small messages, and that turns out to be a relatively low bandwidth network. Therefore, the SRC is not really suitable for large data transfer, as it is very latency focused but not really bandwidth focused. Another option could be the cellular network. A cellular network is very well deployed everywhere. The coverage is almost ubiquitous. However, has a couple of other problems. The first one is that volume of data in cellular networks tends to be expensive or capped. And the second problem is that whenever you put several billion additional users on the road, and those users are actually making traffic like autonomous car, then the infrastructure of cellular network may need very, very substantial upgrades. To give you an example, just think what happens when you are trying to upload your Facebook status to update it with a picture when you are in a concert. You will probably notice that that doesn't work very well, does it? Finally, there is another technology that is already deployed and has been largely overlooked, and this technology is the Wi-Fi. Why am I saying that? Well, if we look at the city of Paris, for instance, what we notice is this basically Wi-Fi coverage. And this Wi-Fi is a very particular type. It's basically managed by a network operator. So is uniform in terms of authentication and quality of the Wi-Fi. In Paris, the largest operator is called Free Telecom. And the way it works from the market standpoint is that whenever you are a customer of Free Telecom, say with your DSL at home or your fiber at home, you are automatically allowed to use their Wi-Fi. This is possible because whenever you are a customer of Free Telecom, you are also sharing your Wi-Fi with other customers of Free Telecom. The authentication is done in network, and Free Telecom takes care of everything, including the fact that the usage from other people will not bother you inside the house. This is not the only case. For instance, for example, in London, the situation is very similar. And while all the operators have this feature, this is the map from British Telecom in downtown London. And actually, this same concept is very popular also across the ocean. And this is what happens in Los Angeles, California, where we use as operator Time Warner Cable that provides Wi-Fi service. everywhere in the city of Los Angeles, and not only Los Angeles, everywhere Time Warner Cable is there. So the idea here is, what if a car can exploit these immense wealth of wireless spectrum that is available to do massive downloads and uploads of data? We introduced then CarFi. CarFi is a technology actually designed to enable cars to exploit available Wi-Fi when they are on the road. We don't see the Wi-Fi as the unique solution, but we see the Wi-Fi as a part of a much larger vision where you have several different types of connectivity in the car. And that type of connectivity will be used opportunistically depending on things like price, availability, bandwidth, needs, and so on. Today, CarFi not only enables to connect to the Wi-Fi, but can be jointly used with the other two technologies like wire over or multipath TCP to support existing applications. Basically, the handover between several technologies or different access points is basically managed by those two technologies, wire over and multipath TCP, and your application in the car will not see anything about it. In the future, this might change because there's a lot of efforts in designing a new internet infrastructure and a new internet architecture that basically might have different ways of managing the transport layer. What are the usage cases? Well, there are many, and that can go from basically safety to connected doctors to news uploads. More specifically, what are the application scenarios where CarFi has something to say? Well, if you look at the application scenarios here in this chart, you see bandwidth against latency, and where CarFi is effective is this gray area here. So CarFi is not the right technology for safety, but becomes the right technology for streaming, internet radios, intelligent navigation, upgrades of head units, map updates, maintenance data upload, autonomous car driving upload. So basically there's a whole set of applications that are suitable for CarFi. Why today this is not possible? Why we cannot just go on the road and use a regular Wi-Fi? Well, if we look a little bit in detail on how the Wi-Fi connectivity works, basically every time we are trying to access a Wi-Fi, our device is first performing a scan, then needs to select the access point among the many available, then needs to associate to that access point, finally needs to authenticate to the access point, meaning that at that point is exchanging the username and password or the credentials if it is like authentication done without username and password, and finally basically requests an IP and gets an IP. Only after this last step we have an IP, so the communication is possible. However, in the current standard stack, that might take between 9 and 14 seconds. And when you are on a car, driving on a road in a city like Paris or in a city like London, you are within the same access point less than 10 seconds. So basically, at the end of this process, you are changing access point and you need to restart. And that is the reason why this is not possible. CarFi is a technology that basically changes part of the process of accessing the network. So the scan is completely redesigned in order to be more effective and more efficient, reducing the time and learning from previous failures and successes. The selection of the IP is done keeping a database that basically maintains which are the IPs that are best performant. So basically that we can pick the right ones wherever we are. The database is geotagged, so we use also information that is geographical. The authentication is basically based on EAP, that is what current providers are using, and we re-engineered it to be very, very efficient in terms of time. And finally, we redesigned and rewritten from scratch the DHCP client in order to be optimized for latency. Bottom line, CarFi access time to an access point is 1 second. And that leaves basically an order of 9-10 seconds available for the communication before you get to the next access point. Furthermore, we think there is still room for improvement, adding, for instance, a distributed database and some other little features in the CarFi protocol. How CarFi supports current applications? Well, CarFi supports it using multipass TCP or using some other proxy-based transport layer today. And specifically in our demo that you will see in a second, we are using MultiP, that is the protocol that is below BitTorrent, is under the hood of BitTorrent. And basically this allows to take advantage of every single connectivity opportunity. CarFi connects your car to the internet over Wi-Fi. While you commute, your car is downloading the next episode of your preferred TV series for free over Wi-Fi. We drove a CarFi car in Los Angeles, connected to the secure Time Warner Wi-Fi. CarFi opportunistically connects to available access points on the road and selects the best one in order to achieve the best performance. While you are driving, your car connects to a new access point usually every 10 seconds. CarFi also works in uplink. You can upload your media or the sensor data for the new autonomous car that you just bought. We drove 14 minutes and 40 seconds, downloading 538.7 megabytes at an average data rate of 4.87 megabits per second with a peak rate of 44.6 megabits per second. Thank you for watching this demo. Feel free to contact us for more information.